June 4th, 1944. 11:09 a.m. North Atlantic. USS Guadalcanal's sonar operator calls out contact. German U-boat 800 yards. Captain Daniel Gallery has trained his entire task group for this exact moment, not to sink the submarine, to capture it alive. 7 minutes later, U-505 breaks the surface, circling helplessly at 7 knots. Lieutenant Albert David leads 8 men through the conning tower hatch into the technological holy grail every Allied intelligence officer dreamed of finding. 2 Enigma machines with current codebooks, Germany's newest acoustic homing torpedoes, complete radio equipment, navigation charts revealing secret U-boat routes. This was it, the prize that would unlock German submarine warfare secrets. But as U-505 gets towed 1,700 nautical miles to Bermuda, something in her logbooks doesn't add up. Her recent combat record tells a different story. 4 consecutive patrols aborted after just days at sea. Equipment failures. Constant breakdowns. 0 ships sunk in her final year of operations. The submarine that represented German engineering superiority had spent 70% of her service life in port for repairs. The first question was, what secrets would U-505 reveal? The real question became, what was wrong with her? Gallery's gamble began months before U-505 surfaced in the Atlantic. Throughout the spring of 1944, he had drilled Task Group 22.3 in procedures that defied every established rule of anti-submarine warfare. Standard doctrine called for immediate destruction, ram the submarine, drop depth charges until oil and debris confirmed the kill, move on to the next contact. Gallery wanted his men to think differently. He wanted them to capture German submarines intact. The idea seemed insane to most naval officers. German U-boats carried scuttling charges specifically designed to prevent capture. Crews were trained to destroy their vessels rather than let classified technology fall into enemy hands. The risks were enormous. Boarding parties could be killed by explosions, booby traps, or desperate crews fighting to the death. But Gallery saw something his superiors missed. Every sunken U-boat took its secrets to the bottom. Every captured submarine could reveal German capabilities, weaknesses, and most importantly, their tactical limitations. On June 4th, the morning air above the North Atlantic carried the metallic scent of diesel exhaust and salt spray as Gallery paced the bridge of USS Guadalcanal. His escort carriers and destroyer escorts had been hunting for 3 days without contact. The convoy routes between Europe and America remained infested with German submarines, but finding them required patience, skill, and considerable luck. At 11:09 a.m., that luck finally arrived. Sound contact? Bearing 090, range 800 yards, the sonar operator's voice cut through the bridge chatter. Gallery moved to the plotting table where his officers were already tracking the contact's movement. The signature was unmistakable. A German U-boat running submerged, probably stalking merchant traffic that had passed through the area hours earlier. USS Chatelaine, designated D-149, moved into attack position first. Her crew had practiced the new capture procedures dozens of times, but theoretical training differed vastly from reality. The destroyer escort's Hedgehog mortars fired first, multiple projectiles designed to detonate on contact rather than at predetermined depths. The weapons found no target. Below the surface, U-505 maneuvered desperately to escape the tightening noose of American warships. At 11:16 a.m., Chatelaine's depth charge pattern detonated in perfect sequence. The underwater explosion sent shockwaves through the ocean that could be felt on every ship in the task group. Gallery watched through binoculars, counting seconds. Standard doctrine suggested waiting for debris, oil slicks, or other evidence of destruction. Instead, He had ordered his captains to watch for something unprecedented, a submarine forced to surface alive. 7 minutes after the depth charge attack, U-505 broke through the Atlantic's surface like a wounded whale. Water cascaded from her conning tower as compressed air expelled seawater from her ballast tanks. The submarine immediately began circling at 7 knots, her steering mechanism apparently damaged by the explosion. German crewmen emerged from the main hatch, some jumping overboard while others remained on deck in apparent confusion. Lieutenant Albert David had been waiting for this moment since Gallery first explained the capture mission. At 44 years old, David brought 25 years of naval experience to his commission as a boarding party leader. He had served as an enlisted sailor through 2 decades of peacetime Navy life before accepting officer responsibilities when war began. His crew respected him because he had earned his authority through seamanship rather than academy training. "Away the boarding party," David commanded as USS Pillsbury pulled alongside the circling U-boat. 8 American sailors followed him across the gap between vessels, each man carrying weapons and equipment needed to secure a potentially hostile submarine. The German crew offered no resistance. Most had already abandoned ship, swimming toward American rescue vessels or floating in life jackets awaiting pickup. David climbed through the conning tower hatch first, his pistol drawn but finding no targets below. The submarine's interior stretched out in cramped compartments filled with machinery, controls, and equipment that represented years of German technological development. Emergency lighting cast strange shadows across unfamiliar instruments, while the acrid smell of battery acid and diesel fuel filled the air. The treasure they discovered exceeded every intelligence officer's expectations. 2 Enigma encoding machines sat intact in the radio room, complete with code books dated for June 1944. The weapons compartment contained 2 G7ES Zaunkönig torpedoes, Germany's newest acoustic homing weapons that Allied naval intelligence had been desperate to examine. Radio direction finding equipment, classified navigation charts showing Atlantic U-boat patrol routes, and technical manuals revealing German submarine capabilities lay scattered throughout the vessel. But even as David's boarding party secured these prizes, questions began emerging from U-505's operational records. Her logbooks told a story that contradicted German propaganda about submarine superiority. The boat's recent combat history revealed troubling patterns of failure and mechanical breakdown that seemed inconsistent with German engineering reputation. 58 German crewmen were pulled from the Atlantic waters that morning. All but one survived the capture. An unprecedented intelligence windfall that would provide interrogators with detailed information about German submarine operations. As U-505 was taken under tow by American vessels, Gallery felt vindicated in his unconventional approach to anti-submarine warfare. The 1,700 nautical mile journey to Bermuda would take several days, during which time Gallery's intelligence officers began their preliminary examination of the captured materials. What they discovered would challenge fundamental assumptions about German naval technology and reveal weaknesses that extended far beyond a single submarine's mechanical problems. U.S. Navy engineers arrived at the Bermuda dockyard in June 1944, expecting to dissect the pinnacle of German submarine technology. Instead, they found themselves staring at a maintenance nightmare that defied every assumption about Kriegsmarine engineering excellence. Chief Petty Officer William Henderson, who had supervised submarine repairs at Portsmouth Naval Shipyard for 12 years, walked through U-505's compartments with growing bewilderment. The German Type 9C submarine represented the enemy's premier long-range attack boat, yet her internal condition suggested chronic mechanical failures that went far beyond battle damage. The pattern emerged immediately in her patrol records. U-505's 5th Patrol, launched July 1st, 1943, had lasted only 13 days before British destroyer damage forced her return to base. Her sixth patrol in September lasted merely 3 days due to electrical system failures. October's 7th patrol, 5 days, terminated by fuel system problems. November's 8th patrol managed only 4 days before radar equipment malfunctions sent her limping back to Lorient. December's 9th patrol stretched to 6 days before engine problems again cut short her mission. Hans Gubler, U-505's machinist's mate, had survived the capture and now found himself answering questions from American technical specialists who seemed more puzzled than pleased by their prize. Through interpreters, he explained the frustrating reality of serving aboard what the Lorient base crew had privately dubbed the problem boat. Every patrol brought new mechanical failures. Systems that worked perfectly during harbor tests developed critical problems within days of submerging. Equipment that German engineers claimed represented the finest submarine technology consistently broke down under operational stress. The human cost of U-505's reliability problems had reached its tragic peak during her 10th patrol on October 24, 1943. East of the Azores, while running submerged during a British depth charge attack, Captain Lieutenant Peter Scheck had been driven to desperation by his boat's failing systems. As explosions rocked the submarine and equipment sparked around him, Scheck drew his service pistol in the control room and shot himself in front of his horrified crew. It marked the first recorded instance of a U-boat commander committing suicide while submerged, a breakdown in leadership that German Naval Command attributed to combat stress rather than examining the systematic failures that had pushed Scheck beyond his breaking point. American intelligence officers studying German patrol records discovered that U-505's problems were not unique. Across the Kriegsmarine submarine fleet, patrol lengths had shortened dramatically since 1942. Type 9C boats that once remained at sea for 60 days now averaged only 23 days per patrol. Equipment-related mission aborts had increased from 12% in 1942 to 34% by 1944. The numbers suggested something far more significant than normal wear and tear. At the German submarine base in occupied Lorient, France, the source of U-505's chronic problems was hiding in plain sight. French dock workers conscripted to maintain German U-boats had developed their own form of resistance warfare, one that left no visible traces but created devastating operational consequences. These electricians, welders, and mechanics had been forced to service the enemy fleet, but they had found ways to fight back through acts of mechanical sabotage so subtle they appeared as routine equipment failures. The resistance cell operated under the leadership of men like Pierre Dubois, an electrician who had worked in Lorient's civilian shipyard before the German occupation. Dubois and his colleagues had spent months studying German submarine systems, learning exactly which components were most critical and which failures would force boats to return to base without appearing deliberately damaged. Their methods required patience, precision, and perfect operational security. A single discovered act of sabotage would result in executions for entire work crews. Their techniques were masterfully simple. Pencil-sized holes drilled in diesel fuel tanks created oil slicks that appeared during routine operations, forcing submarines to surface and reveal their positions to Allied aircraft. Faulty electrical welds on critical systems were designed to fail after specific numbers of diving cycles, creating emergencies that required immediate return to port. Contaminated lubricating oil caused engine seizures that seemed like normal mechanical breakdown. Deliberately weakened radar components failed during combat operations when submarines needed them most. The genius of French resistance sabotage lay in its invisibility. Each individual act appeared to be routine equipment failure. A weld that failed after 200 operating hours looked like normal fatigue, stress. A fuel leak that developed after 50 diving cycles seemed like ordinary wear. Electrical systems that shorted out during heavy weather appeared to be design limitations rather than deliberate sabotage. German engineers investigating these failures found nothing that definitively pointed to enemy action. U-505 had become a favorite target for French saboteurs precisely because of her high-profile status as a Type 9C boat. After one particularly embarrassing aborted patrol, her crew returned to Lorient to find a hand-painted sign posted at their berth reading U-505's hunting ground, a mocking reference to the submarine's inability to remain at sea long enough to hunt anything. The sign disappeared quickly, but the message was unmistakable to anyone who understood the dynamics of occupied Lorient. The scale of French resistance impact was staggering. Lorient housed more than 30 submarines simultaneously during peak operations, serviced by over 2,000 conscripted French workers. These men had access to every critical system on every German submarine that passed through their facility. Sabotage incidents had increased 400% between 1943 and 1944, though German records attributed the problems to material degradation under combat stress rather than recognizing deliberate enemy action. American engineers examining U-505's maintenance records found evidence of the systematic campaign that had crippled her effectiveness, though they initially misinterpreted the patterns as German engineering inadequacies rather than French resistance warfare. The submarine that was supposed to reveal German technological secrets was actually demonstrating something more significant: how ordinary courage could defeat sophisticated military technology through patience, skill, and invisible acts of defiance. Pierre Dubois arrived at Lorient's submarine pens each morning at 6:30 a.m., carrying his electrician's tools and the accumulated rage of 4 years under German occupation. The massive concrete bunkers that housed German U-boats stretched along the French coast like monuments to enemy engineering, their reinforced walls thick enough to withstand Allied bombing raids. Inside these fortifications, Dubois and 2,000 other French workers performed the delicate maintenance that kept the Kriegsmarine's submarine fleet operational. What their German overseers never understood was that these same skilled hands were systematically destroying the war machine they were forced to serve. The resistance cell that Dubois helped coordinate operated under principles of absolute discretion and plausible deniability. Each member was a specialist: electricians who understood German wiring systems, welders familiar with submarine hull construction, mechanics who knew which engine components were most critical. They communicated through subtle workplace signals, building trust through shared risk and mutual dependence on perfect operational security. A single mistake, one act of sabotage traced back to deliberate action, would result in mass executions that would eliminate entire work crews. Dubois had spent months studying the electrical systems aboard Type 9C submarines like U-505. German engineering was methodical and precise, but also predictable. Critical circuits followed standard patterns. Emergency systems operated according to established protocols, and backup equipment was positioned in logical locations. This predictability became the foundation for resistance warfare that appeared as random equipment failure rather than coordinated attack. The methods developed by Dubois and his colleagues required extraordinary patience and technical precision. Drilling pencil-sized holes in diesel fuel tanks was an art form that demanded exact placement and timing. Too large, and the damage would be immediately obvious. Too small, and the leak might not develop for months. The perfect hole would create a fuel leak that appeared after specific operational stresses, diving cycles, surface runs at high speed, or rough weather conditions that flexed the hull. When U-boats returned to base trailing telltale oil slicks, German investigators found exactly what they expected to find: routine mechanical failure caused by combat operations. Electrical sabotage required even greater subtlety. Dubois would identify critical junction boxes where multiple systems converged, then create welds that looked perfect but contained microscopic flaws designed to fail under specific conditions. A radar system that worked flawlessly during harbor testing would short out during the high electrical demands of submerged operations. Emergency lighting that functioned normally in port would fail during depth charge attacks when crews needed it most. Each failure appeared to be the result of design limitations or manufacturing defects rather than enemy action. The contamination of lubricating oil represented perhaps the most sophisticated form of mechanical warfare developed by the Lorient. Resistance. Dubois learned to introduce minute quantities of abrasive particles into engine oil systems, particles so small they passed through standard filters but accumulated over time in critical bearing surfaces. Engines that ran smoothly during initial testing would seize catastrophically after specific operating hours, creating emergencies that forced submarines to surface in dangerous waters where Allied aircraft could attack them. U-505 became a particular focus for French saboteurs because her high-profile status as a Type 9C boat made her failures especially visible to German command. Her repeated aborted patrols created opportunities for additional sabotage during each return to port. Dubois would examine the boat's systems, identify which components had been replaced or repaired, then systematically compromise different systems to ensure that her next patrol would also end in failure. The cumulative effect was a submarine that appeared to suffer from chronic bad luck rather than coordinated enemy action. The psychological impact on German crews was as important as the mechanical failures themselves. U-boat personnel began to lose confidence in their equipment, knowing that systems might fail at critical moments. Hans Gobler later described the atmosphere aboard U-505 as one of constant anxiety about which component would break down next. Crews that should have been focused on hunting Allied shipping instead spent their time troubleshooting mechanical problems and wondering whether their boat would survive its next dive. French resistance operatives developed increasingly sophisticated techniques for avoiding detection. They learned to vary their methods so that failure patterns didn't reveal coordinated sabotage. One submarine might suffer electrical problems while another experienced fuel system failures. Components would be compromised using different techniques to suggest multiple causes rather than systematic action. The timing of failures was carefully planned to occur during operations rather than while boats were in port, making investigation difficult and diagnosis uncertain. The scale of French resistance impact extended far beyond individual submarines. Lorient's maintenance schedule stretched from 8 weeks to 12 weeks as boats required increasingly extensive repairs between patrols. German engineers attributed the problems to material shortages, combat stress, and manufacturing defects in homeland factories. They never suspected that occupied French workers were conducting a systematic campaign of mechanical warfare that was crippling submarine effectiveness throughout the Atlantic theater. By 1944, the cumulative effects of French sabotage had fundamentally altered German submarine operations. Average patrol lengths for Type 9C boats had dropped from 60 days to 23 days. Equipment-related mission aborts had increased from 12% to 34%. Most significantly, submarines were spending 70% of their service life in port for repairs rather than at sea hunting Allied shipping. The French workers who had been forced to maintain German submarines were systematically ensuring that those submarines could not perform their intended missions. The resistance cell at Lorient operated under constant threat of discovery and execution, but their effectiveness increased dramatically as they refined their techniques and expanded their operations. What began as isolated acts of defiance had evolved into coordinated warfare that was more effective than conventional military action. They were defeating German submarines not through direct confrontation, but through invisible acts of mechanical sabotage that accumulated over time into systemic failure. Dubois and his colleagues understood that they were fighting a different kind of war, one measured in failed patrols, aborted missions, and submarines that limped back to port instead of sinking Allied shipping. Their weapons were precision tools and expert knowledge rather than guns and explosives. Their battlefield was the maintenance bay rather than the ocean. And their victory would be measured not in enemy casualties, but in German submarines that could no longer effectively wage war against Allied shipping. At the Naval Torpedo Station in Newport, Rhode Island, Commander James Mitchell supervised the most important weapons analysis of the Pacific War. The two intact G7ES Zaunkönig torpedoes recovered from U-505 represented Germany's newest submarine technology, acoustic homing weapons that Allied naval intelligence had been desperate to examine since reports of their deployment reached Washington in late 1943. These torpedoes were designed to seek and destroy Allied escort vessels, turning the hunter-killer groups that protected convoys into victims of their own aggressive tactics. The Zaunkönig, German for Wren, measured 21 feet in length and weighed 3,500 pounds when fully loaded. Its sleek bronze-colored hull contained sophisticated guidance systems that represented a quantum leap beyond conventional torpedoes that ran straight and true toward predetermined targets. The acoustic homing mechanism used two hydrophone receivers positioned in the torpedo's nose to detect propeller noise from enemy ships. Once launched, the weapon would acquire the loudest acoustic signature in its vicinity and steer towards that target using electro-pneumatic controls that adjusted rudder and diving planes automatically. Technical specifications revealed impressive capabilities that had worried Allied naval commanders since the first acoustic torpedo attacks began appearing in convoy battle reports. The Zaunkönig could achieve 24 knots underwater, faster than most escort destroyers could manage when maneuvering to avoid attack. Its effective range against targets moving between 10 and 18 knots extended to 5,000 meters, giving German submarines the ability to attack from distances that made counterattack difficult. The warhead contained 274 kilograms of hexanite explosive, enough to break the back of any destroyer or corvette in the Allied fleet. But as American engineers disassembled the acoustic guidance system, they discovered a fundamental design flaw that would prove fatal to German submarine warfare. The hydrophone receivers that detected propeller noise were exquisitely sensitive instruments capable of distinguishing between different types of ship engines and propeller configurations. However, this same sensitivity made them vulnerable to deception. The acoustic homing system could not differentiate between genuine propeller noise and artificial sounds generated by simple mechanical devices. Lieutenant Commander Robert Hayes, the Navy's leading expert on underwater acoustics, immediately recognized the implications. The German wonder weapon that was supposed to revolutionize submarine warfare could be defeated by basic acoustic countermeasures. Within days of beginning their analysis, Hayes and his team had identified the specific frequency ranges that triggered the Zaunkönig's homing mechanism. The torpedo was designed to ignore very low frequencies that might come from whale songs or ocean turbulence, and very high frequencies that suggested machinery rather than propellers. But the middle frequencies, the range that included ship propellers, could be replicated using simple noise-making devices. The development of Allied countermeasures proceeded with remarkable speed. By August 1944, just 60 days after examining U-505's acoustic torpedoes, the Navy had deployed Foxer noisemakers throughout the Atlantic Fleet. These devices consisted of metal bars and chains towed behind ships on cables, creating cavitation noise louder than actual propellers when dragged through the water at speed. The Foxer cost approximately $50 to manufacture and could be deployed by any vessel capable of handling a towing cable. Field testing revealed the devastating effectiveness of this simple countermeasure. Zaunkönig torpedoes fired at ships towing Foxer devices consistently homed on the noisemakers rather than the actual targets. The acoustic torpedoes would explode harmlessly in the wake of Allied vessels, their sophisticated guidance systems defeated by crude mechanical noise generators. German submarines launching acoustic torpedo attacks found their most advanced weapons chasing decoy sounds while intended targets escaped unharmed. The broader technical assessment of U-505 revealed patterns that extended far beyond torpedo design flaws. American engineers examining the submarine systems found evidence of overengineering that prioritized technical sophistication over operational reliability. The boat's electrical systems used complex switching arrangements that required specialized maintenance procedures. Her diesel engines incorporated advanced fuel injection systems that improved efficiency but created additional failure points. Navigation equipment featured precision instruments that provided excellent accuracy under ideal conditions but proved fragile under the stress of extended combat operations. Range capability remained impressive. 13,450 nautical miles at 10 knots surface speed gave Type 9C boats global operational reach. Maximum diving depth of 230 feet operational and 295 feet emergency provided adequate protection from most depth charge attacks. The submarine's electronics represented advanced 1944 technology that surpassed Allied equivalents in several categories. Yet these strengths were undermined by critical vulnerabilities that made German submarines increasingly ineffective as the war progressed. Complex systems required specialized parts that could only be manufactured in German factories, creating supply chain vulnerabilities that grew worse as Allied bombing campaigns targeted industrial facilities. Maintenance procedures demanded technical expertise that was difficult to provide in forward bases or occupied territories where submarines operated. Most significantly, the sophisticated systems that made German submarines technologically advanced also made them vulnerable to the kind of subtle sabotage that French resistance workers had perfected. Manufacturing bottlenecks further limited German submarine effectiveness. Only 54 Type 9C boats were ever commissioned throughout the entire war, despite their superior capabilities compared to smaller Type 7 submarines. The complex manufacturing processes required to build these advanced boats meant that German shipyards could not produce them in sufficient quantities to replace combat losses. Each submarine lost represented months of specialized manufacturing capacity that could not be quickly replaced. The maintenance requirements that kept U-505 in port for 70% of her service life were typical rather than exceptional for advanced German submarines. Complex systems broke down more frequently than simple ones. Sophisticated equipment required more frequent calibration and adjustment. Advanced technology demanded higher quality lubricants, fuels, and spare parts that became increasingly difficult to provide as Allied blockade efforts tightened around German supply lines. American naval engineers concluded that German submarine technology represented a classic example of overengineering defeating operational effectiveness. The pursuit of technical perfection had created weapon systems that were theoretically superior but practically vulnerable. Complex acoustic torpedoes could be defeated by simple noisemakers. Sophisticated submarines spent more time under repair than at sea. Hunting enemy shipping. Advanced technology had become a liability rather than an advantage in the harsh realities of extended warfare. The capture of U-505 provided American submarine designers with a comprehensive education in engineering priorities. Post-war American submarines would emphasize reliability over sophistication, maintainability over complexity, and operational availability over theoretical performance. The German submarine that was supposed to teach Allied engineers about advanced technology instead taught them about the dangers of pursuing technical excellence at the expense of practical effectiveness. Captain Daniel Gallery stood in the Pentagon briefing room in September 1944, facing a panel of senior naval officers who had initially dismissed his capture doctrine as reckless experimentation. 3 months after U-505's seizure, the intelligence windfall from his unconventional tactics had fundamentally altered American understanding of German submarine warfare. The Enigma machines had proven less valuable than expected. Allied code breakers were already reading German naval communications through other sources. But the submarine herself had revealed something far more strategically significant than cryptographic secrets. The comprehensive analysis of U-505 systems, maintenance records, and operational history demonstrated that German submarine warfare was systematically self-defeating. Gallery's staff intelligence officer, Lieutenant Commander Patricia Williams, presented findings that challenged every assumption about Kriegsmarine technological superiority. German U-boat production rates were falling behind losses not because of Allied shipbuilding capacity, but because of the complexity and manufacturing bottlenecks inherent in advanced submarine design. Type 9C boats required specialized components that could only be produced in limited quantities by German factories already struggling under Allied bombing campaigns. The maintenance requirements that kept U-505 in port for 70% of her service life were representative rather than exceptional. Across the German submarine fleet, advanced boats spent more time under repair than hunting Allied shipping. Complex electrical systems failed regularly under operational stress. Sophisticated diesel engines required specialized parts that were increasingly difficult to obtain. Advanced navigation and communication equipment demanded technical expertise that was scarce in forward bases and occupied territories where submarines operated most frequently. Gallery's vindication extended beyond technological analysis to strategic implications that reshaped American anti-submarine doctrine. The controversial decision to capture rather than sink German submarines had provided intelligence officers with comprehensive insight into enemy capabilities and limitations that could never be obtained from wreckage on the ocean floor. Every captured submarine revealed operational patterns, maintenance problems, and design vulnerabilities that informed Allied countermeasures and tactical improvements. The French resistance contribution to German submarine failures remained largely invisible to American intelligence analysts who attributed chronic mechanical problems to design inadequacies rather than systematic sabotage. But the cumulative effect was undeniable. Submarines operating from Lorient experienced equipment failure rates 400% higher than boats based in German ports. Patrol durations had shortened dramatically as boats returned to base with increasing frequency for repairs that appeared to address routine wear and tear, but actually reflected coordinated resistance warfare. Pierre Dubois and his colleagues at Lorient continued their invisible campaign through the final year of the war, never knowing how their individual acts of sabotage contributed to broader strategic outcomes. Each deliberately weakened weld, each contaminated oil system, each precisely drilled fuel tank hole represented a small victory in a war fought with precision tools rather than weapons. The French workers who had been forced to maintain German submarines were systematically ensuring that those submarines could not effectively wage war against Allied shipping. By war's end, The statistical evidence of French resistance impact was overwhelming, even though German investigators never identified the coordinated nature of the sabotage campaign. Maintenance-related patrol failures at Lorient had increased 400% between 1943 and 1945. 127 U-boats were lost due to premature surface exposure during the same period, with 31% of these incidents attributed to equipment failures that forced submarines to surface in areas where Allied aircraft could attack them. The human cost of systematic German submarine failure extended beyond combat casualties to psychological breakdown among crews who lost confidence in their equipment. The suicide of Kapitän Lieutenant Peter Scheck aboard U-505 represented an extreme example of leadership collapse under the stress of commanding unreliable vessels. Post-war interviews with surviving German submarine personnel revealed widespread demoralization caused by chronic equipment failures that made successful patrols increasingly difficult to achieve. American submarine doctrine underwent fundamental revision based on lessons learned from U-505's capture and analysis. Post-war American submarines prioritized operational reliability over technical sophistication, recognizing that complex systems created vulnerabilities that enemies could exploit through sabotage, supply chain disruption, or simple mechanical failure under stress. Maintainability in forward bases became a primary design criterion, ensuring that American submarines could remain operational even when operating far from home ports with limited maintenance facilities. Redundant systems replaced single-point failure designs throughout American submarine architecture. Where German boats incorporated sophisticated but vulnerable single systems, American designs featured multiple backup capabilities that could maintain operational effectiveness even when primary systems failed. Simplicity became valued over complexity as engineers recognized that reliable, simple systems outperformed unreliable, sophisticated ones under operational conditions. The strategic lessons from U-505's capture extended throughout the American military establishment. Overengineering could defeat operational effectiveness just as surely as underengineering could compromise performance. The pursuit of technical perfection could create vulnerabilities that enemies could exploit through unconventional warfare methods. Complex supply chains and specialized maintenance requirements could become strategic liabilities when operating in contested environments where logistics support was limited or compromised. Gallery's legacy influenced American military thinking for decades after the war ended. The capture doctrine he pioneered demonstrated that intelligence gathered from intact enemy systems could be more valuable than the immediate tactical benefit of destroying those systems. Understanding enemy capabilities and limitations provided strategic advantages that extended far beyond individual engagements to influence entire theaters of operation. The quiet heroes of Lorient received no recognition during their lifetimes, their contributions hidden by the very success of their invisible warfare methods. French resistance workers like Pierre Dubois returned to civilian life without knowing that their patient, precise acts of sabotage had contributed significantly to Allied victory in the Battle of the Atlantic. Their legacy lived on in the shortened patrols, aborted missions, and mechanical failures that crippled German submarine effectiveness during the war's final years. The submarine that was supposed to represent German technological superiority instead became a symbol of how ordinary courage could defeat sophisticated military systems through intelligence, patience, and unwavering commitment to resistance. U-505's capture revealed that the most decisive battles were sometimes fought not with weapons and explosives, but with precision tools and expert knowledge applied by people who refuse to accept occupation and defeat.